Hello, everyone. My name is Alex McConnell. I'd like to welcome you to today's webinar of Netacea, How Bots Win. And presenting today is my colleague, Cyril Noel-Tagoe. Cyril, welcome.
Thanks, Alex. Hi, everyone. My name is Cyril Noel-Tagoe. I'm the Principal Security Researcher here at Netacea. And today I'd like to talk about how bots win. Now, automated business logic attacks are nothing new. But if the recent news of the PS5 and other games consoles being scalped is anything to go by, these attacks are becoming more high profile and more impactful to organizations. So how do bots win? Well, to understand how these bots win, first we need to understand their life cycle. How does a bot attack actually work? I'm going to go through the 6 phases of a typical bot attack. These are defined in the Business Logic Attack Definition or BLADE framework. And these detail the distinct phases that a bot goes through. Now, these phases might not always go through in the same order, and depending on the goals and the objectives of the adversary, they may skip out some phases. But this model gives a good view and a good understanding of how bot attacks work. So if we start with resource development, the first phase in most bot attacks is for the adversary to actually develop the tools, the infrastructure, or the credentials they need for that bot attack. If we take a credential stuffing bot as an example, the adversary needs a set of credentials to launch at their target. The next phase, which sometimes is done in conjunction with resource development and sometimes before, is reconnaissance. Here, the adversary needs to do some research on their target. They want to understand things like, how does the business logic of the target work? What is the best time to launch an attack on this target? What defenses does the target have in place? Using this information, they can move into the next phase, defense bypass. See, once they know the defenses that are in place, they can develop strategies and tactics to bypass these defenses. Once the defenses are bypassed, they can move on to actually executing their attack. In the case of a credential stuff on the bot, this may be actually taking over the account. But there are other use cases. See, a bot may be there to actually create accounts. It may be there to perform fake interactions. For example, clicking on ads if it's an ad fraud bot, or posting comments for a spam bot. It might also be purchasing items, as in the case of the spoken about scalper bots. Now, once the attack has been executed, the adversary might want to do some additional actions on their objective. So if they've created an account, they might want to monetize their accounts in some way. If they've taken over an account, they might want to transfer some information from their account, whether that's personal information or maybe payment details. And finally, in the post-attack phase, the adversary wants to, monetize their attack, but maybe off the target. So they've got the items that they scalped and they need to resell those. Now, understanding this bot attack lifecycle, I wanted to hone in onto the defense bypass phase, because as I said at the start, bot attacks are not new. There are some defenses that people have been putting in place and the bot developers are expecting and are getting ready to bypass. So let's look at a few of these. So according to the BLADE framework, there are 4 tactics that a adversary will typically use to try and bypass defenses. Now, I'm not going to go into all of those in this webinar, but I'd like to pick on a few of those. Those are going to be proxying, human emulation, and 2 techniques for mitigation bypass. So let's start with proxying. The goal here for the adversary is to bypass IP-based protection. Now, generally, there's 2 types of IP-based protection. One is an IP denialist. So if an adversary is going from a known bad IP address, let's block that address. And the other is IP rate limiting. So if we have multiple attacks coming from the same IP address, let's block that. And generally, the request flow will look something like this. So the adversary and the bot is making multiple requests to a web server or to launch their attack. Now, proxying, the adversary is going to distribute those requests through some intermediary IP addresses. And what happens is, instead of having multiple addresses coming from this one maybe known bad IP address, these requests are now coming from a multitude of IP addresses. If one of these is blocked, the adversary can rotate to another IP address. And in fact, these IP addresses may look like IP addresses from your actual customers as well, especially when we look at residential proxies. Now, this is an advanced technique that many adversaries are using. See, a residential proxy looks exactly like the IP address of your typical user. In fact, it might be the IP address of one of your typical users. You see how residential proxy providers get these IP addresses is generally they offer an SDK as part of a mobile app. Now, as a user, I might sign up, I might download this app, and I might opt in to being part of this peer-to-peer network in exchange for not being served adverts on the app. Now, whilst my device is not being used by me, my IP address is available for people who purchase this residential proxy to use. You see, in this case, I could be one of your customers and I could legitimately be using your web service. And then once I stop, an adversary could go through my IP address and use that web service as well. So you can't block on just an IP address because that's going to impact your legitimate customers. And on the screen, there are just two of the biggest residential proxy providers here. And key to note here is their success rates they're placed in, and also the size of their pools. You know, these aren't small pools of IP addresses. These are millions of IP addresses, and an adversary can afford to rotate an IP address in every request. So there's no way that IP rate limiting is going to work in this case. Let's look at another technique that adversaries use. So human emulation. Now, most bot detection technologies are looking to find out behaviors which are bot related and not human related. So the goal here is to bypass this. Client-side scripts look to take telemetry from a browser. So whether that's the actual browser configuration or the way that the browser is being interacted with to determine if it's a bot or it's a user. Now, there are different techniques that an adversary might use to bypass this, but at the core of it, they're trying to mimic human behavior. And one example technique is mouse usage. See, the way that a automated program is going to move a mouse and the way that a human will move a mouse are vastly different. Generally, an automated program is going to go straight from one element to the other element that it needs to input in. And there's going to be no variation in how that movement occurs. And that's quite easy to detect. Humans are a lot more, they're a lot more different in the way they interact. You know, they might go somewhere, they might have a slight curve, they might change their mind as they're going somewhere. And so it's not quite random, but it's not as straight as a bot would do. Now, because that difference in behavior, people have started to develop emulations which try to mimic that human behavior. And this is just one example, Ghost Cursor, which is publicly available on GitHub. Now, they claim to generate realistic human-like mouse movement data between coordinates and elements, like the definitely not robots you are. Now, this isn't a repository which is not visited very often. This has thousands of weekly downloads. See, these repositories are working enough for people to be interested in and to be downloading them. And once you can mimic the human behavior, the signals that are being sent back by the telemetry are going to tell that this is a human operator, which is going to bypass that type of bot detection. And what about other client-side bot detection? Well, see, the problem with client-side bot detection is that it's visible to the adversary. See, client-side bot detection is generally done through JavaScript, and JavaScript is served with the web page. This means that an adversary can take the time to analyze and circumvent the detection logic in the JavaScript. Now, generally, a bot protection provider is going to go to great lengths to obfuscate that code. They might even run that code inside a virtual machine. But at the end of the day, the code is still visible. If that means an adversary with enough time or enough commitment can break through it. So let's look at an example of some JavaScript that is being de-obfuscated. You see, the original JavaScript might look unreadable. But if the adversary is skilled enough, they can take the time to actually output what the JavaScript is actually doing. Now, this is just a trivial example, but this is showing a GitHub library which can de-obfuscate some common JavaScript obfuscation techniques. And this can be automated. So for a bot protection provider to be able to obfuscate their code in a way that makes it difficult for an adversary, they need to be using techniques which aren't common. They need to be developing their own in-house techniques. And this will slow down an adversary, but it won't stop a motivated adversary. And the result of that is that the provider is going to need to change that code to kind of counteract in this cat and mouse game with the adversary. And this may mean that you need to redeploy code. But that's if the provider knows that the code's being broken. You see, some adversaries have actually posted bypasses for JavaScript bot protection on GitHub. But that doesn't mean those are the only bypasses there are. You see, it's much more advantageous for an adversary to hide the fact that they've actually bypassed a JavaScript protection. If they can keep it to themselves, they can keep exploiting this protection without you knowing for long periods. So the fact that there actually are some down on GitHub begs the question, how many are there that are not on GitHub? Now, knowing that adversaries can bypass this JavaScript protection, are there any other solutions? Let's look at CAPTCHAs. CAPTCHAs are probably the most well-known bot protection solutions. Since Google's reCAPTCHA with the kind of the text that they use for OCR to the kind of more common detect how many traffic lights there are, which I seem to keep failing because, I'm obviously a bot. But the problem with CAPTCHAs is they're at a point where they have to make them very difficult for bots not to be able to automatically detect. And once you get to that point, the adversaries are actually thinking, the one thing a CAPTCHA has to do by definition is let a human pass it. So let's farm these CAPTCHAs out to humans to actually pass for us. And that's what you get with CAPTCHA farms. You see, for very low prices, about 50 cents for 1,000 solved CAPTCHAs, an adversary can actually just farm out or outsource the CAPTCHA challenge to a pool of human operators who will solve the CAPTCHA and provide the code back for the bot to continue its activities. So even the CAPTCHA doesn't work. So, in summary, bots will attempt to bypass your defenses. It's a core part of the bot attack lifecycle. From resource development through to post-attack, they are trying to understand your defenses and bypass those. So you need an advanced bot management solution that's going to stay ahead of the advanced bots. And this can't be a solution which is advertising to the bots how it's going to try and mitigate them, because the adversary is going to study that and develop tactics and techniques to bypass that. This is where Netacea comes in. You see, we received the top score in the bot detection criterion in the first Forrester Wave for bot management. This means we were the best bot protection provider that they analyzed at detecting bots.
Thanks, Cyril. So just got a quick question off the back of all that. So knowing now how bots are bypassing these defenses, in some of the examples you've given there, how would we go about detecting the bots that are using these techniques?
Sure. So let's look at I think Proxying was the first example I gave. So let's look at Proxying. So in Proxying, the goal there is to hide the true IP address that the adversary is using and to kind of send their request through multiple intermediaries. So you can't use IP blocking and you can't use IP rate limiting. What we do is we use machine learning and anomaly detection so we can understand the intent of the traffic. That means we don't have to rely on the IP address solely or the geographical location that it's tied to. And we can take the signals in concert with other signals and actually determine where there's kind of spikes in traffic and other anomalies. I think the second one I mentioned was telemetry. So things like human emulation and particularly mouse movement. See, we're agentless. We sit server side. We don't have any JavaScript agent that is trying to collect telemetry signals, which means that an adversary can't spoof those signals, right? No matter how they move their mouse, that's not going to affect our detection logic. And then kind of the third one I mentioned there was the JavaScript, right? So they're trying to kind of bypass the client-side JavaScript. Again, we don't sit client-side. We're agentless, so there's no JavaScript for an adversary to study and to develop bypasses against.
Right. So why is it that we've chosen this path then? Is it just because we know that JavaScript is visible to the user? So what's the advantage of us doing it, like you say, the server side, not using agents?
Yeah. So we know that bots can spoof human behavior, with mouse movements. We know that adversaries can take the time to study client-side code. You can spend a lot of effort trying to obfuscate it, but adversary can similarly spend just as much effort, maybe more effort, to de-obfuscate it. If they're motivated enough, they will do it. So instead, we looked at a different way. Now, with client-side, you're looking at signals, you're looking at behaviors and trying to take from that the intent of an adversary. We flip that on itself. We say, let's look at the actual intent of an adversary and let's use that to detect bots. You see, at the end of the day, the bot has to make certain requests to achieve their objectives. And by analyzing those requests, we can identify the actual intent of the bot. And you can fool signals, you can spoof behaviors, but at the end of the day, you can't spoof your intent. You've got to do what you have to do to achieve your goals. And that's the approach we've taken.
Thanks, Cyril. And you mentioned about CAPTCHA as well there. I mean, that's not a foolproof detection method, as you mentioned. Is it still sort of valid in the kind of bot detection or mitigation space though?
But yeah, so as you said, yeah, CAPTCHA as a full solution, it's just not effective. Where CAPTCHA can play a role, and what we see with some of our customers is they like to use it as a soft block. So we may suspect a user is bad, but maybe they don't have the confidence or they don't have the risk appetite to do a full block on that user, in which case they may serve a CAPTCHA. As I said earlier, it's very easy for bot operators and adversaries to bypass CAPTCHA, so that should only ever be served as kind of a soft block mechanism.
Yeah, it makes perfect sense. All right, thanks very much, Cyril, for that. If you've got any other questions, of course, you can email hello@netacea.com and we can pass those to Cyril or someone else on the team to answer those questions. But in the meantime, thanks again, Cyril, for joining us. And thank you for watching.
Thanks, everyone. Bye-bye.